we want to divide 8 times the 4th root of 3y by 5 times the 4th root of 8x. Well, what we want to do is to rationalize the denominator. You need a list of your fourths, because you have to do this, we're going to multiply both numerator and denominator by whatever it takes to make the denominator the 4th root of a perfect power. Now you'll still just have the 5 here, so that will be the same. But I've got to get the 4th root of a perfect power. Now look in your list of fourths. 8 is not a fourth, but 16 is. 16 is a perfect fourth. And of course, x to the 4th would be a perfect fourth. Now I'm getting these numbers from the list of fourths that I had you make in tape 121. So if you do not know where these perfect powers are coming from, go back and listen to tape 121. It's near the first of it, in which I showed you how to get these perfect powers. Now the question is, what do you multiply 8x by to get 16x to the 4th? Whatever the answer is, I multiply both numerator and denominator here by the same thing. Be sure you're using the 4th root. So 8 are going to 16 2 times, so I have to multiply by 2, and x and x to the 4th is x cubed. So I have to multiply by x cubed. So I'm multiplying by the 4th root of 2x cubed. If I multiply the denominator by the 4th root of 2x cubed, then I multiply the numerator by the 4th root of 2x cubed. You have to multiply the denominator and numerator by the same thing. So now I have, when I multiply, that would be the 5, the 4th root of 16x to the 4th, and the top is going to be 8 times the 4th root of, now 3 times 2 is 6, x cubed, y. And both of these had the same index, so I could multiply them. Now I take the root of the denominator, so it's going to be 8 times the 4th root of 6 x cubed y divided by 5 times, okay, taking the root now, the 4th root of 16 is 2, the 4th root x to the 4th is x. So that would be 8 times the 4th root of 6 x cubed y divided by 10x. And one should always reduce fractions. So, and notice the 8 and 10 are both out from under the radical, so they can be reduced. So it would be 4 times the 4th root of 6 x cubed y divided by 5x. 2 going 8 4 times, 2 going 10 5 times. Let's look at another example. Let's simplify the cube root of 12 x squared y to the 9th divided by 6 x cubed y to the 11th. This exponent 3 is hard to see because it's hard to write big enough so that it doesn't blend with the ink, but that's a 3. Well, you always want to work inside symbols of inclusion first. So I'm just going ahead and reduce inside. 6 is going to 12 2 times. Okay, we've got x squared over x cubed. I can say x squared goes in x squared 1 time, x squared goes in x cubed x. I've got y 9th, y the 11th, so that's going to be y squared. So we would have the cube root of 2 over xy squared once I reduce it. So always reduce inside the radical before you start your work. Now this could be written as the cube root of 2 over the cube root of xy squared. Now here's your critical step. I've got to have a perfect cube in the denominator. That's the only way you can get rid of the cube root. Now x, if I have x, that means I've got to multiply by something and get x cubed. I have y squared, so I've got to multiply by something and get y cubed. So that means I need to multiply both numerator and denominator by x squared y. What do you multiply x by to get x cubed? What do you multiply y squared by to get y cubed? So I have to multiply both numerator and denominator by the cube root of x squared y. So that leaves the numerator now, if I do the multiplying, the cube root of 2 x squared y. Now I take the root of the denominator, so it would be the cube root of 2 x squared y divided by xy. The cube root of x cubed is x, the cube root of y cubed is y. Rationalizing the denominators combined with reducing the radicand can allow us to simplify things that look to be unalike. Let's look at 1 divided by the square root of 2x minus the square root of 8x cubed divided by 3x squared. Now what I need to do is to rationalize this one. So I have 1 over the square root of 2x, and I can multiply it by the square root of 2x over the square root of 2x, because I'm asking what does it take to get a perfect square. Why, in order to get the perfect square would be 4x squared. What do I need to multiply 2x by to get a perfect square? It would be 2x. 2x times 2x is 4x squared. 4x squared is a perfect square. Minus, okay, I'm going to break this one up into 4x squared times the square root of 2x. I'm left over 3x squared. I break it up into what is a perfect square and what's not. So this leaves me with the square root of 2x over 4x squared minus 2x times the square root of 2x over 3x squared. Square root of 4x squared is 2x. And I've still got the square root of 4x squared here. Square root of 2x times square root of 2x is square root of 4x squared. So now I have the square root of 2x over the square root of 4x squared is 2x minus, I've got 2/3 times the square root of 2x over x. Because notice, this x will cancel with one of those x's, leave me with x. Or I have 1/2 times the square root of 2x over x minus 2/3 times the square root of 2x over x. So now I have like terms. Since these terms are alike, they can be combined. To combine them, I need a common denominator, which is 6. So it would be 3/6 times the square root of 2x over x minus 4/6 times the square root of 2x over x, which is a negative 1/6 times the square root of 2x over x.